Welcome to today's lesson. What we're going to try to do today is learn to determine whether a number is a solution of an equation. This is going to be fun. We're going to finally get into balancing equations and getting to add, subtract, multiply, and divide in totally different ways. Make sure you have this written down before moving on. Here's your warm-up. Just 6 problems that I want you to solve for. And all you got to do is plug and chug. You're going to plug in 8 for every single one. Come back when you're done. We'll see how you did. So here are the answers you should have gotten. 29, 16, 9, 16, 55, and 5. Again, all I did is I replaced the x's with 8s, and then I used order of operations, doing parentheses first, which we didn't have any, exponent second, which we didn't have any. We did it multiplying, then dividing, and then adding and subtracting delta in here. So hopefully you got all those correct. All right, so a couple notes I want us to write down before we actually get into some problems. Today we're going to actually start dealing with equations. We've been doing a lot with expressions, but now we're going to do something with equations. And equations are mathematical statements that have 2 expressions that are equal. Okay? An expression, remember, is something on each side of the equal sign, or it's a problem or an answer that needs to be dealt with. As we work through equations, we're going to be trying to have a value that is a solution. A solution here is basically an answer. Okay, it's being solved. So if we look at our balance scales here before we move on, the one thing you'll notice is that the one on the left looks like it's unbalanced. The 4 times 2 is heavier than the 6. Where over here, this equation, or this balance beam is equal, where 3 plus 2 and 5 are equal. Well, you know 3 plus 2 equals 5. 4 times 2 does not equal 6, and that's what it's trying to show you here. That to solve an equation, you have to have a balanced scale. Both sides need to be the same value. And that's important as we move on to know that you're trying to find the same value. Only thing I really want you to write down before moving on are the 2 vocabulary. So here's one more example where we can look at an equation, equal signs, so it's got to be an equation, with s plus 15 equaling 27. Well, if we did some plug and chug, and I told you to plug in 12 for s and plug in 10 for s, and you looked at our balance beams here, you can see what we get. If we put 12 in here, that would have been x, and 12 plus 15 is 27. This is an equal solution. You can see they're balanced. So we use the equal sign. Sometimes it will say plug and chug a number like 10. Well, if we put 10 in for x, 10 plus 15 is not 27, it's actually 25. That will mean it's not equal to, and you say not a solution. So we're going to have a couple problems like that where we're going to look at whether it's a solution or not a solution, simply by plugging and chugging and seeing what we get. All right, I want to go through a few practice problems with you where you can see how this plugging and chugging will tell us if we have a solution or not. So here our equation is b minus 447 equals 1,203, for b equaling 1,650. Whenever you see this whole part, this is the plug and chug. That's the plug and chug part that basically is telling you 1,650 is what you're plugging in for b. Now if you do that, and you subtract 1,650 from 447, what you get is 1,203. Well, is 1,203 equal to 1,203? There we go. The answer is yes. So in this scenario, we have what's called a solution. So this is a solution because it has the same value. All right, let's look at another one. Before moving on, make sure you copy this down as an example of a solution. So this one you would say solution for your answer. Okay, copy this down, then we'll look at another one. Here's another one where we're looking at 27x, which remember means 27 times x, equals 1,485 for x equaling 54. Okay, so if we look at our problem here, it's 27 times x. I made it red. So you see what we're going to work with. It equals 1485. So we're going to plug and chug. We're going to plug in 54 for 27. And if we go ahead and figure out what 54 times 27 is, and just so you know I'm cheating a little, I'm going to use my calculator. We get 1,458. Now, if you look at both numbers on the sides of the equal signs, the solutions here, they all have a 1, they both have a 4, they both have a 5, and they both have an 8, but they're in different orders. So this would be an example of not a solution. Okay, solution or not a solution. So it's your choice if you want to write this down. I would, because now you have an example of seeing one that works with a balanced scale and seeing one like this that's not balanced. All right, your turn. I have 6 problems up here that you're going to plug and chug for, and you're going to find out if they are solutions or not solutions. So for example, number 1, when you plug in 35 for C, it's 35 plus 23. Well, that would be 58 equaling 48. Does that work? Nope, so that's not a solution, so you just have to say no. Hey, look, I gave you one. Now you can go ahead and try to figure out the other 5. All right, so hopefully you got the same answers I did. For number 1, you know is no. Number 2, I got yes, it is a solution. 73 equals 73. Same with 3, 96 equals 96. 4 was a no, because I got 89, that doesn't equal 85. 5 was a yes, 5 equals 5. And 6, we had a remainder, that clearly told me it's not a solution. Hopefully you did well on the first section here. Just want to spend some time here with our second practice looking at word problems. So in this one it says Paulo says that his yard is 19 yards long. Jamie says that Paulo's yard is 664 inches long. Well, we have to determine which 2 measurements are equal. So this is a cool problem because we're looking at 2 different measurements and trying to see if they're equivalent. Well, first thing you need to know is how do you get from yards to inches? Well, each yard is 3 feet long, and each foot is 12 inches. So all I did is I did 12 times 3, and I got 36. So basically, we're going to do 36 times whatever yards here and see if it equals the inches. So we plug and chug. We're going to plug 19 in for the yards. We're going to multiply it by 36 inches because that's what 1 yard equals. It's our ratio. And when you do that, you find out that 36 times 19 is 684. So that is not a solution. So the question said, determine if these 2 measurements are equal. The answer would be no, they are not. Actually, 19 yards is larger, it looks like, than what is actually thought of. Here's another example. You could probably copy this one down in your notes. It says Anna says that the table is 7 feet long. John says the table's 84 inches long. So you have to determine whether these 2 measurements are equal. Now I know by 6th grade you already know that there's 12 inches in a foot. So if we just multiplied 7 by 12, that would get us inches. So again, we're going to plug and chug. We're going to put in 7 where we see the question marks. Okay. And the other thing we know is that we're looking to see if it equals 84 inches. So we can replace these question marks with 84. And now when we do 12 times 7, what do you get? 7 times 2 is 14. Carry the 1. 7 times 1 is 7, plus 1 is 84. So if we look at this, we do see that it is a solution. These 2 measurements are equal. So your answer would be yes, it is equal. Or because 84 equals 84, the box will get out of the way here, 7 feet is equal to 84 inches. So there's an example of a solution and not a solution. Here's an example I want you to try on your own. Tell me if these waterfalls are equal or not. Come back when you're done. And you should have seen, like I did, that yes, these 2 values are equal just by trying to balance them and seeing if they match correctly. All right, go ahead and solve your box of thoughts. For number 1, you're going to tell me if y divided by 2 equals 9, which one works when you plug and chug, 14, 16, or 18? How do you know? And then give an example of an equation with a solution of 15. Remember, you're writing an expression on one side equaling 15. So you can write an equation using 2 numericals or 1 numerical and 1 variable. And here's your quiz for today. You have 5 questions. Again, for 1 through 4, you're plugging and chugging. And for number 5, you're going to tell me, is this a solution or not? Did Kylie actually pay the correct amount or not for the pizza? Good luck, and can't wait to see your notes. Yippee, yippee, yay.